Did you know your aircraft is certified to a probability? Every structural part is designed to a statistically defined strength, not an absolute guarantee. This isn't a compromise. Rigorous testing, safety factors, and statistical confidence are exactly what make aviation so safe. Welcome to Aerosif Pravaha, bringing you fascinating aviation facts. Let us understand why theory fails. Even with alloy specification, dimensions, and load, engineers cannot predict exact failure because material behavior and first failure remain inherently variable. Fracture mechanics predicts crack growth accurately, but first failure of real manufactured parts remains dominated by unavoidable material variability. Microscopic grain variations remain invisible, yet significantly influence material strength. Random porosity, inclusions, and stresses make every manufactured part unique. Small dimensional tolerances significantly alter stress concentration and structural failure load. Environment and loading history continuously influence a part's structural strength. The reason for the probabilistic approach is the inherent scatter of the strength values. Let us take 13 identical aluminum specimens, manufactured similarly, failed at different loads despite identical material, processing, and testing conditions. Failure load variation is normal, not a manufacturing quality problem. Designing to average strength leaves half the parts dangerously weak. Advanced composites exhibit greater failure variability due to manufacturing imperfections. Allowable values are set by the following 4 steps. Step 1. Test. Hundreds of specimens tested across all relevant environments. Raw failure data recorded. Step 2. Fit. Data fitted to a statistical distribution, typically normal, log normal, or Weibull. Goodness of fit tested rigorously. Outliers are investigated, never simply discarded. Step 3. Compute. B basis or A basis computed from the fitted distribution. This is the number that goes into the stress engineer's analysis, not the mean, not the minimum test result. Step 04. Knockdown. Additional factors applied for environment, wet, hot versus room temperature dry, joint efficiency, damage tolerance requirements, and fatigue. The final design allowable used in stress analysis is lower still. Look at the probability distribution. The B basis sits on the left tail. Everything to the right of it, 90% of the population, will fail at a load higher than the allowable. The designer assumes the part is at least this strong. Statistically, 9 out of 10 actual parts are stronger. B basis is the material value exceeded by at least 90% of parts with 95% statistical confidence, ensuring reliable design, allowable despite finite testing and natural manufacturing variability. B basis applies to redundant primary structures with backup load paths, while A basis, which is 99% probability of 95% coincidence, is reserved for single failure critical components, requiring greater confidence and more conservative material allowables. Aviation is safe because of statistics, not despite them. Material allowable already include realistic variability, ensuring systematic conservatism without requiring engineers to apply additional personal safety margins. Material allowable require continuous testing whenever materials, processes, or environments change, keeping MMPDS updated with reliable aviation design data. Commercial aviation's exceptional safety record reflects rigorous use of probabilistic material allowables across every certified aircraft structure worldwide. Thanks for watching. Please subscribe for more aviation facts. Have an aviation question you've always wondered about? Leave it in the comments.